Hi again everyone. Welcome to our third tutorial on circular functions, and in this session we're going to be looking at exact values of sine, cosine and tangent in the unit circle. These exact values are related to special angles in the unit circle, and in quadrant 1 these special angles are 30 degrees, 45 degrees and 60 degrees. There are also special angles in the second, third and fourth quadrants, and these special angles are all related to these basic angles in quadrant 1. These angles are special because sine, cosine and tangent of these angles can be expressed as exact values as well as decimal approximations. Not all angles in the unit circle have this property. These exact values constantly reoccur in the unit circle and must be remembered and used constantly by students if they are going to study trigonometry effectively. These exact values can be derived from two different right-angled triangles, which we will examine in detail now. First of all, let's look at sine, cosine and tangent of 30 degrees and 60 degrees. To do this, we need to look at the triangle that you can see in front of you now. It's an equilateral triangle, which means that all three sides are equal and all three angles are the same size. We can see in this triangle that we have one side here which is equal to 2, and being an equilateral triangle, that means that this side here must also be equal to 2, and the base of our triangle is equal to 2. If all three angles in the triangle are the same, and we can see that this angle here is equal to 60 degrees, then the other base angle over here will also be equal to 60, and our angle at the apex of the triangle will also be equal to 60. The next thing we need to do is we need to draw a perpendicular line from the base of the triangle down to the apex of the triangle down to its base. It bisects the base here, and in the process also bisects this angle up here. If it bisects the base, we know that this length here, which is half of the base, will be equal to 1. We already know that the hypotenuse is equal to 2. This angle here will also be bisected, which means that it now becomes 30 degrees. We now have a right-angled triangle which is comprised of this perpendicular line here, this base here, and this hypotenuse. We need to find the length of this perpendicular side, and we'll call this unknown length A. We're going to use Pythagoras' theorem to find this length, and we know that Pythagoras' theorem says that A squared plus B squared is equal to C squared, where A is my unknown length here, B is equal to 1, and C, the hypotenuse, is equal to 2. So, using Pythagoras' theorem, we'll say A squared plus 1 squared is equal to 2 squared. A squared plus 1 is equal to 4. A squared must therefore be equal to 4 minus 1, which is 3, and A must be equal to the square root of 3. Now that we know this unknown side is equal to the square root of 3, we have all the information that we need to find sine, cosine and tangent of 30 degrees and 60 degrees. Let's start with 30 degrees. If we're looking at sine of 30 degrees, we know that the sine ratio is equal to the opposite side over the hypotenuse. In this triangle, the side opposite 30 degrees is 1 and the hypotenuse is 2. So sine of 30 degrees is equal to 1 over 2 or a half. Now let's look at cos of 30 degrees. We know that the cos ratio is equal to the adjacent side over the hypotenuse. The side which is adjacent to 30 degrees is the square root of 3 and the hypotenuse is 2. So cosine of 30 degrees is equal to root 3 over 2. Finally, let's look at tan of 30 degrees. Now we know that the tan ratio is equal to the opposite side over the adjacent side. With this 30-degree angle, the opposite side is 1 and the adjacent side is root 3. So tan of 30 degrees is equal to 1 over root 3. Now let's look at 60 degrees. Let's find sine of 60 degrees, which we know will be equal to the opposite over the hypotenuse. The opposite side to 60 degrees is root 3 and the hypotenuse is 2. So sine of 60 is root 3 over 2. Cosine of 60 degrees will be equal to the adjacent side over the hypotenuse. Our adjacent side to 60 degrees is 1, our hypotenuse is 2, so cos 60 degrees is 1 over 2 or a half. Finally, tan of 60 degrees. Now tan is opposite over adjacent, as we know, and the opposite side to 60 degrees is root 3 and the adjacent side is 1. So tan of 60 degrees is equal to root 3 over 1, which is equal to root 3. So we can see here that when we're looking at the 30-degree angle and the 60-degree angle, the exact values we're concerned with are 1/2 root 3 over 2, 1 over root 3, and root 3. All of these values have decimal approximations as well. We know that a half is equal to 0.5. Root 3 on 2 is equal to 0.8660 as a decimal approximation. 1 on root 3 is equal to approximately 0.57. And the square root of 3 is approximately equal to 1.73. Now let's look at sine, cosine and tangent of 45 degrees. In order to do this, we need to analyse this triangle that you can now see before you. This is an isosceles triangle, which means that it has two sides which are equal, and in this case our two equal sides are the perpendicular sides. This side here which is 1 and this side here which is 1. Here we have a right angle. The hypotenuse here is equal to the square root of 2, and this is found by using Pythagoras' theorem again. If we take one perpendicular side to be A and the base to be equal to B and my hypotenuse as C, we can say that 1 squared plus 1 squared is equal to C squared. 1 squared is equal to 1, so 1 plus 1 is equal to C squared, and 2 is equal to C squared. This means that C must be equal to the square root of 2, and that's where this value comes from. We can use these three values to find sine, cos and tan of 45 degrees. Let's start with sine. If we're finding sine of 45 degrees, we know that sine is the opposite side over the hypotenuse. The side opposite 45 degrees here is 1, the hypotenuse is root 2. So sine of 45 degrees is 1 over root 2. If I use this 45 degree angle under here, I get exactly the same answer. The opposite side is 1, the hypotenuse is root 2. Now let's look at cosine. Cosine of 45 degrees is equal to the adjacent side over the hypotenuse. If we look at this 45 degree angle again, we can see that the adjacent side is 1 and the hypotenuse is root 2. So cosine of 45 degrees is also equal to 1 over root 2. Finally, let's look at tan. We know that tan of any angle is equal to the opposite side over the adjacent side. In this triangle, if we use this angle down here, we can see that the opposite side is 1 and the adjacent side is 1. So tan of 45 degrees will be equal to 1 over 1, which is equal to 1. So with regard to 45 degrees, we can see that the exact values we're concerned with here are 1 on root 2 and 1. 1 on root 2 has a decimal approximation as well, and that's 0.7071. The exact values of sine, cosine and tangent of 30 degrees, 45 degrees and 60 degrees are summarised in this table. If we look at 30 degrees here, sine of 30 degrees is a half, cos of 30 degrees is root 3 on 2, tan of 30 degrees is root 3 on 3. You'll remember earlier when we found tan of 30 degrees, we found that our answer was 1 on root 3. I can rationalise this value by multiplying it by root 3 over root 3. And if I do this, the answer that I get is root 3 over 3. So this value here is the same value as 1 on root 3. It's just been rationalised. If we look at 45 degrees over here, sine of 45 degrees is root 2 on 2, cos of 45 degrees, root 2 on 2, tan of 45 degrees is equal to 1. Once again, this value here has been rationalised. We found that cos of 45 degrees was 1 over root 2. If we rationalise this value by multiplying it by root 2 over root 2, we end up with a value of root 2 over 2. So this value here is the same value as 1 on root 2. Finally, we have 60 degrees. Sine of 60 degrees is root 3 on 2. Cos of 60 degrees is a half, and tan of 60 degrees is root 3. This ends our tutorial on the exact values of sine, cosine and tan in the unit circle. I hope you found it enjoyable.